Warahmatullahi wabarakatuh. We're from the Cubesat team of FGC 2021, and today we're going to present about our Cubesat prototype. Before that, my name is Fateh. This is Gauti. This is Nindra, and this is Oscar. So let's talk about the mission. So the mission here is to make a weather forecast cube satellite that will act as primary source of weather data above the ground. It will record all data about the weather and provide valuable inputs for computer forecast models to further predict and forecast the weather.
So this is our design process. So our main function is to record data about the weather, and from that it can be broken up functions such as the sensor, the data transmission. From that, some functions can be as we made two designs, and we chose the second design because it's better than the first design, and we started to test everything individually so we know that everything works properly, and then we test the temperature and UV together, and then we combine all sensors and store it in the SD card, and it can be transmitted back to Earth. For the launch, we used a weather balloon that is provided from the FGC kit. So the functions are to read the sensors such as the temperature, air humidity level, atmospheric pressure, so the UV index, and read the time, and also the GPS. And it also stores data and also transmit the data to backup. So this is our design idea.
Okay, prototyping. The design was carried out using FGC, an open source CAD software for the design of electronic hardware, and breadboard was used for early prototyping before it was wired and soldered using a permanent circuit. Prototype design was carried out using FGC to support one to move from experimenting with the prototype building a more permanent circuit. See figure 2.2.1. Early design prototyping was carried out for each component and assembled onto one circuit using a proto board before it was soldered in the PCB. This is us, hardware assembling using breadboard, then hardware wiring and soldering in the circuit board.
So this is the transmit or flowchart for the Cubesat. So first, start the program. We then initiate the sensors. We start the package, and then we read all the sensors. What this means is that it collects data such as pressure, humidity, and temperature. Then all of this data is then stored as packet data. Then finally, it is transmitted. The question is the balloon altitude still increasing? Is the current pressures less than the previous pressure? If this is true, this program keeps repeating itself. If it's false, then the program stops. This is the receiver flowchart for the Cubesat. So it starts the program, then it initiates the receiver. The question is it receiving data? If it is receiving data, the data is fed to a serial monitor, and it keeps repeating this process. But if it's not true, then it stops the program. This is our Fusion 360 cube design.
So here is the programming code, here's the initiating code and the sensor reading code. Here's the data storing code and the data transmit code.
Okay, this is our final design. We use all sensors that provided by first, and we add an additional component which is a LoRa as the transmitter. This is our final Cubesat. And 10x10x10 dimension.
So before we launch the Cubesat, we first test all the sensors and then we test the storing the SD card. So first we test the individual touch sensors, and this is the program. And next, we test the UV plus the temperature sensor together, and then we combine everything together and test it into a one system. And use our and after that we test the transmitting system with the LoRa. As we can see, we transmit it to the laptop, and finally we test the Cubesat with a drone to make sure everything works properly in the air. And after that test succeed, that means our Cubesat is ready to launch.
Function. Due to the complicated permission issue, the team then decided to do the launching within the facilities of BMKG, Republic of Indonesia Agency of Meteorological, Climatological, and Geophysical Republic of Indonesia. Figure 4.2.1 on the right side shows the team picture with the Cubesat prototype at BMKG vicinity. The launching was carried out on 18 September 2021 when the weather was clear at specific time at 13.
From here, the Cubesat was launched on 18 September 2021. From here, it shows that the Cubesat was working and it keeps sending the data while it's being received also. In the maps, the data stopped at 1 kilometers because the area was a free frequency area, which shows that it doesn't receive any frequency at the time.
So after we launch the Cubesat, we input all of the data to a spreadsheet, then turn it to a graph which is called the stove diagram, and it's commonly used in weather analysis and forecast. From this stove diagram, we can use the pattern of the temperature and dew point to predict the weather in the near future.
From our lesson learned in making this prototype, we learned to work as a team and hone our skills in engineering, programming, wiring, and collaborating. In the process of developing and coding the Cubesat, there were a number of failures. LoRa and GPS caused so many issues that we also were confused. But in the end, the team managed to overcome it and taught us always to find a way in looking for solutions and not to be fooled.
So we thought we didn't need a parachute and GPS, but after a few study literatures, we learned that we actually needed the parachute and the GPS to find out weather variables such as wind speed and wind direction. To estimate the weather phenomena, the team admitted didn't use the parachute and we didn't use the parachute and the GPS, and lots of valuable data was lost. This is a precious lesson to be prepared and use all possibilities to get all the experiment results.
Huge appreciation to First Global for allowing us to participate in this competition, which taught us many valuable things from engineering, programming, wiring, and collaborating. And also special thanks are due to BMKG, Indonesian Agency of Meteorological, Climatological, and Geophysical for the facilitation and help during the launch of the Cubesat into the stratosphere at their facilities. Okay, that's all from us. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.